All right, all barbecue joints are places that serve coleslaw. Therefore, some barbecue joints are places that serve coleslaw. Now, remember from our conversation about existential import that from the Boolean standpoint, any argument that has a universal premise, an all or a no statement, and a particular conclusion, a statement that begins with some, is an invalid argument. It commits the existential fallacy, right? Remember, from the Boolean perspective, universal statements, all statements and no statements, they don't imply that their subject category is an actually existing thing. And as a consequence of that, we can't draw a particular conclusion from the universal statement because the particular conclusion asserts that some of these things, at least one, actually exists in reality. And you can't base that statement on an assertion that all or no of that thing are included in or excluded from a particular category. You can see this reflected in the modern square of opposition, which is associated with the Boolean standpoint, where we have corresponding A and I statements and corresponding E and O statements connected with broken lines. Their relationships are logically undetermined. So this argument is invalid from a Boolean standpoint. But now let's adopt Aristotle's standpoint, the Aristotelian standpoint. Remember what Aristotle says. Aristotle says, waste of time to be talking about things that don't exist. So when I assert that all of something are included in a category, or all of them are excluded from a category, I'm implying that the things I'm talking about exist. Now, with that thinking in mind, if we assume it's true that all barbecue joints are places that serve coleslaw, would it have to be true that some barbecue joints are places that serve coleslaw? Would there have to be at least one that does? And the answer is yeah, it would. It would be the case, okay? And what we're seeing here is what's called the rule of subalternation. The rule of subalternation applies to corresponding A and I statements and corresponding E and O statements, okay? So you'll notice that instead of a broken line on our square of opposition, we have a solid line. And we have a couple of other lines that are really important, and it's important you take note of this. This green arrow, starting at the top of the square on A and on E, and running down to its corresponding I claim or corresponding O claim, means this. If you have an A statement or an E statement that's true, that value of true trickles down the side of the square to show that its corresponding I statement or O statement is also true, okay? So that truth value trickles down. You'll also notice another line. It's a red one, and it has as its beginning the letter F and an arrow that points up to A and an arrow that points up from O to E. And what that's saying is this. If you have an I statement or an O statement that you know is false, that false value floats up the side. I don't know why I'm doing this. That false value floats up the side of the square to identify the corresponding A statement or E statement to also be false. Okay? So now you look, we've given our square a whole bunch of new lines compared to the modern square of opposition. This is called the traditional square of opposition, and it's associated with the Aristotelian perspective. So you can see that when we work from the assumption that the things we're talking about are actually existing things, there's a lot more things we can do with different kinds of statements. We're going to explore that in the next a couple of lectures. We'll explore that, okay? So the traditional square of opposition is associated with the Aristotelian perspective. We use this square when evaluating arguments from the Aristotelian perspective. We use the modern square when we're evaluating arguments from the Boolean perspective. And you can see that while both squares share in common the rules of contradiction, you'll also see soon that they also share the operations of conversion, aversion, and contraposition. But the traditional square has a lot more rules associated with it. It has the rule of contraries, subcontraries, and subalternation. And we can use all of these eventually to evaluate arguments for validity. Okay? So the rule of subalternation says this: the truth value of a true A or E statement trickles down to the corresponding I or O statement. And corresponding is super important, right? That the exact same subject and predicate terms. The truth value of a false I or O statement floats up to the corresponding A or E statement. Okay, so if I'm given an argument like this one, no wolves are good house pets, therefore some wolves are not good house pets, I can use my traditional square of opposition to evaluate this argument just by simply identifying where my premise is, identifying where my conclusion is, and identifying whether or not it's going to be the case that if it's true no wolves are good house pets, will it also be true that some wolves are not good house pets? And the rule of subalternation says, yeah, that truth value trickles down. So this argument is valid by subalternation. Similarly, look at this argument. It is false that some degenerates are good business partners. Therefore, it is false that all degenerates are good business partners. Okay, my premise statement is an I statement I'm being told is false, and I can see right here that false value floats up to the corresponding A claim and makes that statement also false. And that's exactly what the conclusion says. Okay, so we can use the rule of subalternation, subcontrary, and contraries, as well as conversion, aversion, and contraposition to evaluate and create arguments. And evaluate them for validity and create valid arguments.